Hey guys, how's it going? So from my last ordinary differential equations video, I showed you how to solve an exact equation, but it's not very common for equations to be exact, and it's more common for them not to be exact than exact. So the question is, what can we do in that case? And we use something called an integrating factor, and you can either do it with respect to x or with respect to y. So first thing, let's label this m and n. So m is 3x squared y plus 2xy plus y cubed, and n is x squared plus y squared. They're not going to be exact, but let me just show you that they're not. So m sub y is equal to 3x squared plus 2x plus 3y squared. And n sub x is equal to 2x. They are not equal, so they're not exact. What we do here is we can do something called an integrating factor. And you can do it either with respect to x or with respect to y. We're going to show you how to do it with respect to x first. So here is the formula for the integrating factor. We call it mu. D mu of dx is equal to m sub y minus n sub x, m sub y minus n sub x over n times mu. And we just plug in. So this is 3x squared. I can just write this. So 3x squared plus 2x plus 3y squared is m sub y, and n sub x is 2x, so these two cancel out. You're left with 3x squared plus 3y squared. Over x squared plus y squared. And that equals 3. So d mu dx is 3. D mu dx is 3 mu. Sorry, I missed the mu here. 3 mu. So d mu over dx is 3 mu. And when you, this is a separable differential equation. So let's move all the variables to one side. All those d mu over, sorry guys, I'm a little out of it right now. D mu over 3 mu is dx. And integrate both sides. And you end up with 1 over 3 ln mu is x plus c. Absolute mu is x plus c. Ln mu is 3x plus 3c. And mu, I'm going to do it slowly. I don't like to make mistakes. So the absolute value of mu is e to the power of 3c times e to the power of 3x. And when you take mu, you can just plus or minus this. So it's pretty obvious that mu is CE3x. Because plus or minus e to the power of 3c is just still a constant c. And since it could be any c, let's just call it e to the 3x. So that's our factor here that we're going to make the equation exact. So I called this part 1. Part 2 is just plugging it in. Before I continue, I will say there's a caveat, though, with this integrating factors method. If at the end of this solving this d mu over dx thing, if your end result has x and y variables mixed together, then it won't work. And the same thing when I show you the formula for y. Like if you have any x variables in y, it won't work. Here, we didn't have any y variables in this mu equation, so it works. Otherwise, not all of the equations can be solved. In fact, most equations can't be solved. You're solving the ones that can be. So mu m is e to the power of, so remember this equation, I'm just applying the integrating factor here, e to the power of 3x. And then just 3x squared y plus 2xy plus y cubed dx plus x squared plus y squared dy is 0. And mu m, here is our m and here is our n with the mu now. So m sub y is equal to e to the power of 3x can be treated like a constant here. Let's see, so that's 3x squared plus, let's see, 3x squared plus 2x plus 3y squared. N sub x is shoot, I forgot to include the e to the power of 3x here. Sorry, that was an oversight. N sub x is 3e3x x squared plus y squared plus e to the 3x times 2x. N sub x is equal to, let's see, 3x. Okay, so no, let's do it this way. Let's take a factor of e to the 3x. So let's see, that would be, here it would be 3x squared. When you take out the e to the factor of 3x here, that's 2x. So plus 2x plus 3y squared. These two equations are the same. So this equation is exact, and we can use our regular way of solving it with Cactus. So let's erase some stuff here. Hope you had a good chance to look at this stuff. I'm assuming you haven't had enough time, so we're gonna just erase it and just start working through. All right, let's see. I'm gonna do this too, so nothing gets in the way. Cactus sub x of xy is equal to e to the power of 3x x 3x squared y plus 2xy plus y cubed. Okay, and I'm gonna do something, I'm gonna expand it out so it will be easier to integrate. So this is also equal to 3x squared e to the 3xy plus 2e to the 3x xy. Actually, I'm gonna, 2x e to the 3xy. So I'm not doing anything new here. I'm just expanding this out. Plus y cubed e to the power of 3x. Okay, now when you integrate it with respect to x, you obviously have to you have to do this with integration by parts. I'm gonna skip the integration by parts. I already did it by myself. So yeah, just give me a sec. 3x squared e to the power 3x. That is equal to, so this part is equal to x squared e to the 3xy minus 2 over 3x e to the 3xy plus 2 over 9 e to the 3xy that looks like a Q. Plus 2 over 3x e to the 3xy minus 2 over 3 e to the xy. Sorry, 2 over 3 e to the 3x y. All right. Plus 1 over 3 e to the 3xy cubed. Plus h of y. And remember, we're adding the h of y here because when you differentiate this with respect to x, h of y goes to 0. So now we have this. Let's differentiate it with respect to y. So cactus sub y of xy is equal to x squared e to the 3x, obviously because the y cancels. Oh, I almost forgot. Let's simplify this. So this cancels out with that. 2/9 plus 1/3 is 2/9. Yeah, that's. Wait, hang on. Give me a sec. I think I make a mistake somewhere. 2/9 minus 2/3. Yeah, that's equal to 4/27. Yeah, okay. No, let's do it this way. Yeah. Plus 2/9 e to the 3x. E to the 3, no, sorry, not y. E to the 3x minus 2/3 e to the 3x. Yeah, this was this was what I wanted to change. Plus e to the 3xy squared. Yeah. Plus h prime of y. And this equals, let's just simplify it now before things get any more complicated. X squared e to the 3x minus 4/9 e to the 3x plus y squared e to the 3x plus h prime y. All right. Now, from comparing this with this, it's clear from this and comparing this, h prime y is equal to 4/9 e to the 3x. Because, yeah, they have to be equal. This and this has to be equal. 4/9 e to the 3x. And so that means h of y is equal to 4/27 e to the 3x. All right, so our final solution is cactus sub xy is equal to, let's see, x squared e to the 3xy plus, let's see, 2/9 minus 4/9 e to the 3xy e to the 3x y plus 1 over 3 e to the 3xy cubed plus 4 over 27 e to the 3x. And that is the answer. Let's see what happens with y here. Yeah, give me a second. I'll be right back. So here is one where we're going to use the case of y. As you can see, m sub y is not equal to n sub x. I'm not going to show it this time. You can verify that for yourself. But we could use an integrating factor with respect to y. And with respect to y, here is the formula for it. Mu of y is equal to e to the power of the integral of q of y dy. Don't worry, I'm going to show you how to do this in a sec. So q is equal to n sub x minus m sub y over m. So n sub x minus m sub y all over m. And q is equal to, so n sub x would be 5x. Yeah, 5, n sub x is, sorry, 5y minus, let's see, so 5y minus, yeah, because this is, there's nothing here for x, minus 1 over y, which is equal to 5 minus 1 over y. So it works because we don't have any variables related to x. So mu is thus, applying this equation in, it's e to the power of 5 minus 1 over y dy. Which is equal to e to the 5y divided by e to the ln y or simply put, e to the 5y over y. Now, we can apply the integrating factor here, e to the 5y over y to both here and here. And when you do so, you end up with e to the 5y plus e to the 5y over y. No, sorry, you don't have to. Yeah, so I'm skipping a step. So when you multiply the integrating factor out to here, you end up with 5x e to the 5y minus 1 over y primed is equal to 0. And these are exact, this is exact. You can use the exact same way I did it before. I'm going to leave this as an exercise to you to figure out how to do it. But when you get to the bottom, applying similar concepts, using cactus of x and cactus of y, you end up with cactus of xy will be equal to x e to the 5y minus ln y equals c. Minus ln y will be equal to c. I hope you enjoyed today's video, guys.